Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P2 Variant 1, May-June 2020. Let's get started. Rectangle A measures 3 cm by 8 cm. 5 rectangles congruent to A are joined to make a shape. Work out the perimeter of this shape. So from the diagram, we can make out that the sides with length 8 cm are 6 in total, the sides with length 3 cm are 6 in total, and the sides with length 2.5 cm are 8 in total, and this gives us a perimeter of 86 centimeters. Find the highest odd number, that is a factor of 60 and a factor of 90. We first need to list the prime factors of 60 and 90. Then we map out these prime factors in a Venn diagram. In the overlap section of the Venn diagram, the product of any of the two numbers give us a factor of 60 and 90. But in this case, we are looking for the factor that is the highest, and that is an odd number as well. 2 times 3 gives us 6, which is not an odd number. 2 times 5 gives us 10, which is not an odd number. 3 times 5 gives us an odd number, which is also the highest number. And so our highest odd number factor is 15. Mrs. Salaman gives her class 2 mathematics tests. The scatter diagram shows information about the marks each student scored. Write down the highest mark scored on test 1. So from the graph, we can map out the highest point scored in test 1, and that is 66. Write down the type of correlation shown in the scatter diagram. So from the graph, we can see that a general increase in the scores for test 1 lead to a general increase in the test 2 scores. And so this is a positive correlation. Draw a line of best fit on the scatter diagram. So to draw your line of best fit, the general rule of thumb is to draw the line through the maximum number of points while balancing an equal number of points above and below the line. Hamish scored a mark of 40 on test 1. He was absent for test 2. Use your line of best fit to find an estimate for his mark on test 2. So on the graph, we map out 40 on the test 1 axis and trace it to our line of best fit. The corresponding mark for test 2 that we get is 46.5, and so that will be our final answer. A bag contains blue, red, yellow, and green balls only. A ball is taken from the bag at random. The table shows some information about the probabilities. Complete the table. So to complete the table, we know that the sum of all the probabilities must be equal to 1. So to find the probability of picking a yellow ball, that will be 1 minus the sum of the probability of picking the blue ball plus the red ball plus the green ball, and that gives us a final answer of 0.22. Abdul takes a ball at random and replaces it in the bag. He does this 200 times. Find how many times he expects to take a red ball. And so we know that the probability of picking a red ball is 0.2. And so to find the number of times he expects to take a red ball, we will multiply that probability times 200, and that gives us a final answer of 40. The nth term of a sequence is 60 minus 8n. Find the largest number in this sequence. The largest number in this sequence is when n equals 1. When n equals 1, we have 60 minus 8 times 1, and that gives us a final answer of 52. Any number greater than n equals 1 gives us a value lower than 52. Here are the first 5 terms of a different sequence. Find an expression for the nth term of this sequence. So from the given sequence, we can see that there is a general increase of 7 amongst the terms. And so to find the nth term for a sequence with a common difference, we use the formula an equals a1 plus n minus 1 times d, where an represents the nth term, a1 represents the first term in the sequence, which is 12 in this case, and d represents the common difference, which is 7. So after substituting these values into the formula, we arrive at a final expression of 7n plus 5 as the nth term. The diagram shows a trapezium. Work out the value of x. So from the diagram, we have two parallel lines, and so we can identify angles A and B as consecutive angles. Consecutive angles add up to 180 degrees, and so this means that 97 minus 3x degrees plus 69 plus 5x degrees equals 180 degrees. And when we simplify this and make x the subject, we get a value of x as equal to 7. Use this information to write 438,048 as a product of its prime factors. And so from the given information, we know that 438,048 can be rewritten as 234 times 1872. So when we put in 234 as 2 times 3 squared times 13, and we also put in 1872 as 2 raised to the power 4 times 3 squared times 13, we are able to apply the laws of indices to simplify the expression. So in the next step, 2 times 2 raised to the power 4 gives us 2 raised to the power 1 plus 4. 3 raised to the power 2 times 3 raised to the power 2 gives us 3 raised to the power 2 plus 2. 13 times 13 gives us 13 raised to the power 1 plus 1. And so when we simplify this further, we get a final answer of 2 raised to the power 5 times 3 raised to the power 4 times 13 squared. Without using a calculator, work out 2 whole number 1 over 3 minus 7 over 8 times 6 over 25. You must show all your working and give your answer as a fraction in its simplest form. So in the first step, we convert the mixed fraction 2 whole number 1 over 3 into an improper fraction, which gives us 7 over 3. Then in the next step, we work on the expression in the brackets by finding the LCM, which is 24. 3 goes into 24 8 times, multiplied by the numerator, which is 7, gives us 56, minus 8 goes into 24 3 times, multiplied by the numerator, which is 7, gives us 21. And so in the next step, 56 minus 21 all divided by 24 gives us 35 over 24, multiplied by 6 over 25. And when we further simplify this, we arrive at a final answer of 7 over 20. Factorize completely 21a squared plus 28ab. So the common factor here is 7a, and when we factor that out, we are left with 3a plus 4b, and that will be our final answer. Factorize completely 20x squared minus 45y squared. So in this case, the common factor is 5, and when we factor that out, we are left with 4x squared minus 9y squared. We can identify 4x squared minus 9y squared as a difference of 2 squares, and so we can rewrite that in the next step as 2x all squared minus 3y all squared. We can further factorize that as 2x plus 3y, 2x minus 3y, and so our final answer is 5 times 2x plus 3y times 2x minus 3y. Points A, B, C, D, E, and F lie on the circle center O. Find the value of x and the value of y. So to find the value of x, we know that the angle that chord AB subtends at the center O is twice the angle it subtends at the circumference. And so this means that x is equal to half of 110 degrees. And so that gives us x equals 55 degrees. So to find angle y, we know that the angle subtended by chord ED at one point on the circumference of the circle is equal to the angle the same chord subtends at another point on the circumference of the circle. And so this means that y is equal to 24 degrees. The diagram shows the speed time graph for 90 seconds of a journey. Calculate the total distance traveled during the 90 seconds. So whenever we are given a speed time graph, we know that the total distance traveled is equal to the area under the graph. And in this case, we can split up the area under the graph as A1 and A2, where A1 is the area of a trapezium and A2 is the area of a rectangle. And so we have half of 6 plus 12 times 30 meters plus 12 times 60 meters, and that gives us a final answer of 990 meters. Gemma records the times in seconds taken for a group of children and a group of adults to complete a puzzle. The box and whisker plot shows information about the times taken for the children to complete the puzzle. Find the interquartile range of the times taken for the children to complete the puzzle. So we know that the interquartile range is equal to the upper quartile minus the lower quartile. So from the box and whisker plot for the children, the upper quartile is equal to 70 seconds and the lower quartile is equal to 48 seconds. And so when we subtract these two values, we get an interquartile range of 22 seconds. The table shows some information about the times in seconds taken for the adults to complete the puzzle. On the grid above, draw the box and whisker plot for the adults. So for the adults, the lower quartile is equal to 42, the upper quartile is equal to 70, and the median is equal to 58. And so that forms the rectangular part or the box part of the box and whisker plots. From the table, the minimum value is 28 seconds and the maximum value is 75 seconds. And so we will plot these as the whiskers of our box and whisker plots. C lies on a circle with a diameter AD, B lies on AC, and E lies on AD such that BE is parallel to CD. AB equals 21 centimeters, CD equals 18 centimeters, and BE equals 13.5 centimeters. Work out the radius of the circle. So from the diagram, we can see that we have two similar triangles, triangle ABE and triangle ACD. So first, let's find the length of AD, which is the diameter of the circle. Then from there, we can find the radius of the circle. So by setting up our equation for the lengths of the similar triangles, we have AD over AE equals CD over BE. And so when we make AD the subject, we now have CD over BE times AE. We are interested in finding the radius of the circle, and that is equal to half of AD. So we've been giving the length of CD as 18 centimeters, and we've also been giving the length of BE as 13.5 centimeters. We've not been given the length of AE directly in the question or on the diagram, but we can use Pythagoras theorem to find the length of AE. And so by applying the Pythagoras theorem, AE equals the square root of 21 squared plus 13.5 squared centimeters. And so when we type this into the calculator, we have the value of the radius as 16.6 centimeters, correct to 3 significant figures. F of x equals 4x plus 3. G of x equals 5x minus 4. F of g of x equals 20x plus p. Find the value of p. So to find f of g of x, we take out the x letter in f of x and replace it with g of x. And so we have 4 times 5x minus 4 plus 3 equals 20x plus p. When we expand the brackets, we have 4 times 5x giving us 20x, 4 times negative 4 giving us negative 16, and plus 3. And so we have 20x minus 16 plus 3 equals 20x plus p. When we compare both sides of the equation, we see that the 20x on both sides of the equation cancels out, and we are left with negative 16 plus 3 equals p. And negative 16 plus 3 gives us negative 13. And so our final answer is p equals negative 13. H of x equals 5x minus 1 divided by 3. Find h inverse of x. So in the first step, let's replace h of x with x and replace x with y. So we have x equals 5y minus 1 divided by 3. When 3 goes across to the other side of the equation, we now have 3x equals 5y minus 1. And when we make y the subject, we have y equals 3x plus 1 divided by 5. And this expression of y is the same as h inverse of x. And so h inverse of x is also equal to 3x plus 1 divided by 5. P, R, and Q are points on the circle. AB is a tangent to the circle at Q. QR bisects angle PQB. Angle BQR equals x degrees and x is less than 60. Use this information to show that triangle PQR is an isosceles triangle. Give a geometrical reason for each step of your work. So we know that QR bisects angle PQB, and so if angle RQB equals x degrees, then angle PQR is also equal to x degrees. Based on the alternate segment theorem, since angle BQR has been given as x degrees, then angle RPQ is also equal to x degrees. So since we know two angles in triangle RPQ and both of these angles are equal and less than 60 degrees, then it means that triangle RPQ is an isosceles triangle. M is inversely proportional to the square of p minus 1. When p equals 4, m equals 5. Find m when p equals 6. In mathematical terms, let's write m is inversely proportional to the square of p minus 1. And so this means that m is equal to a constant, which we are going to call k, divided by p minus 1 squared. So to find k, we are going to slot in the values of p and m given in the question. And so that gives us 5 equals k divided by 4 minus 1 all squared. When we simplify this and make k the subject, we get k equals 45. So now we have m equals 45 divided by p minus 1 all squared. When p equals 6, we have m equals 45 divided by 6 minus 1 squared. And when we type this into the calculator, we get the value of m as 1.8. M equals 5, 7. Find 3m. So 3m equals 3 times the vector, which is 5, 7. This is equal to 3 times 5, 3 times 7. 3 times 5 gives us 15, 3 times 7 gives us 21. And so our final answer is 15, 21. The vector VW equals 10, negative 24. Find the magnitude of the vector VW. So to find the magnitude of vector VW, that is equal to the square root of 10 squared plus negative 24 squared. And when we type this into the calculator, we get 26. OABC is a parallelogram. OA equals P and OC equals Q. E is the point on AB such that AE is to EB equals 3:1. Find OE in terms of P and Q in its simplest form. So we know that OE equals OA plus AE, and AE can be rewritten as 3/4 AB. AB can also be rewritten as AO plus OC plus CB. OA is equal to P, AO is equal to negative P, OC equals Q, and CB equals P. When we simplify this, we get P plus 3/4Q as our final answer. P equals 2 times W plus H. W equals 12, correct to the nearest whole number. H equals 4, correct to the nearest whole number. Work out the upper bound for the value of P. In mathematical terms, let's rewrite 12 correct to the nearest whole number and 4 correct to the nearest whole number. So to find the upper bound of W, we ignore the minus and we have 12 plus 0.5, which gives us 12.5. 4.5. To also find the upper bound of h, we ignore the minus sign and we have 4 plus 0.5, which is equal to 4.5. So to find the upper bound of p, that will be equal to 2 times the upper bound value of w, which is 12.5, plus 2 times the upper bound value of h, which is 4.5. And when we type this into the calculator, we get the upper bound of p as 34. The diagram shows cuboid ABCDEFGH of length 20 centimeters and width 5.5 centimeters. The volume of the cuboid is 495 centimeters cubed. Find the angle between the line AG and the base of the cuboid ABCD. So from the illustration on the diagram, the angle between the line AG and the base of the cuboid has been labeled as alpha. And to find the value of alpha, we can apply SOHCAHTOA. So in this case, that gives us tan alpha equals GC over AC. So let's find the value of the length GC. We've been told that the volume of the cuboid is 495 centimeters cubed. We know the length of the cuboid as 20 centimeters and the width as 5.5 centimeters. And so when we slot these values into the formula for finding a cuboid, we can find the height of the cuboid, which is the same as GC. And this gives us a final value of 4.5 centimeters. Let's find the length AC. So to find the length AC, we can apply Pythagoras theorem, and that gives us AC squared equals AD squared plus DC squared. When we slot in the values of AD equals 20 and DC equals 5.5, we get the value of AC as 20.74247 centimeters. So now we can slot in the lengths of GC and AC in our original equation, and that gives us alpha equals tan inverse of 4.5 centimeters divided by 20.74247 centimeters. When we type this into the calculator, we get the value of alpha as 12.2 degrees, correct to 1 decimal place. The curve y equals x squared minus 2x plus 1 is drawn on a grid. A line is drawn on the same grid. The points of intersection of the line and the curve are used to solve the equation x squared minus 7x plus 5 equals 0. Find the equation of the line in the form y equals mx plus c. The equation of this line is y equals 5x minus 4. Expand and simplify. X plus 3 times x minus 5 times 3x minus 1. So let's expand the first two brackets. X times x gives x squared. X times negative 5 gives us negative 5x. 3 times x gives us 3x, and 3 times negative 5 gives us negative 15. So after expanding the remaining two brackets, we now have 3x cubed minus 6x squared minus 45x minus x squared plus 2x plus 15. And so finally we have 3x cubed minus 6x squared minus x squared giving us negative 7x squared minus 45x plus 2x giving us negative 43x and plus 15. So our final answer is 3x cubed minus 7x squared minus 43x plus 15. Find the area of a regular hexagon with side length 7.4 centimeters. So as shown in the illustration, a regular hexagon can be split into 6 equilateral triangles. And since we know one side length of the hexagon, it means that all the sides of the equilateral triangle will also be equal to 7.4 centimeters. Each angle in the equilateral triangle is also equal to 60 degrees. So with all these information, we can now find the area of the hexagon. So the area of the hexagon is equal to 6 times triangle OAB. And to find triangle OAB, that will be equal to half times OA times OB times sine alpha. OA and OB is equal to 7.4 centimeters and alpha is equal to 60 degrees. And so when we slot these into the formula and type the resulting expression on our calculator, we get a final value of 142 centimeters squared, correct to 3 significant figures. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.